Imagine stepping onto the surface of Mars, not as explorers from Earth, but as Martians returning home. This thought isn't just a fantastical leap, it's a doorway to a profound question that has tickled the minds of scientists and dreamers alike. Did life actually begin on the red planet? Mars, with its haunting landscapes and mysterious allure, has always been a canvas for human curiosity. Historical observations once hinted at canals and possible Martian civilizations, sparking a blend of scientific and fictional narratives. Today we're not discussing Martian folktales, but rather a compelling scientific possibility. What if Mars, with conditions possibly conducive to early life forms, was the cradle of life itself? This video delves into the intriguing scientific theories that propose life might not have started on Earth, but was instead seeded here from Mars, a process known as Panspermia. So, what if the red soil of Mars was once home to the first spark of life? To understand the possibility of life on Mars, we dive deep into the planet's past. Imagine a Mars not as the red, dusty landscape familiar to us today, but as a world brimming with possibilities, where rivers once flowed and vast oceans sprawled under a thicker, warmer atmosphere. Long ago, Mars's environment may have resembled Earth's own cradle of life. Scientists believe that around 4 billion years ago, the red planet was warm and wet, conditions that are typically ideal for life to flourish. The evidence? Mars rovers and orbiters have relayed back to Earth fascinating data and images. Take, for instance, the Viking missions of the late 1970s. These were the first to hint at Mars's more habitable past. The Viking landers conducted experiments that searched for life, and though the results were inconclusive, they laid the groundwork for future explorations. Fast forward to 1997, and the Pathfinder mission took this further by discovering rounded rocks and conglomerates, clear indicators that ancient rivers once carved their paths through Martian landscapes. The intrigue deepens with the more recent missions. Rovers like Spirit, Opportunity, and Curiosity have uncovered signs of ancient water flows and even complex organic molecules in Martian soil. These organic compounds are the building blocks of life as we know it, composed primarily of carbon and usually formed in the presence of water. Curiosity's adventures through Gale Crater have been particularly revealing. The rover analyzed sediment layers, finding patterns and compositions similar to those created by Earth's rivers and lakes. Such discoveries suggest that Gale Crater was once filled with water, potentially habitable for microbial life. Moreover, the repeated detection of methane spikes in Mars's atmosphere by Curiosity poses an exciting question. Could these be biologically produced? On Earth, a significant amount of methane is a byproduct of life, primarily from organisms like bacteria. As we piece together these Martian clues, it becomes increasingly plausible that Mars was once home to life forms thriving in its rivers and lakes. The pieces of the puzzle suggest Mars was not always the barren desert we see today. From Mars to Earth, a journey across the cosmos. Imagine for a moment that life as we know it did not start in the warm, primordial pools of Earth, but was instead delivered from the heavens, a gift from the red planet, Mars. This is the essence of Panspermia, a bold theory suggesting life can hitch rides across the universe, tucked away in the nooks and crannies of meteorites. The concept of panspermia isn't new, but has gained a fascinating angle with discoveries of Martian meteorites on Earth. Scientists have found over 100 meteorites that originated from Mars, ejected into space by powerful impacts, and eventually finding their way to our planet. Among these cosmic travelers, some contain structures that intriguingly resemble biological cells. Though not definitive proof of life, these structures fuel the imagination and scientific inquiry about the possibilities of interplanetary life transfer. Consider the mechanics of such a journey. A rock harboring life forms is blasted off Mars's surface by a meteor impact. It travels through the harsh environment of space, survives the fiery descent through Earth's atmosphere, and lands perhaps in a quiet desert or a frozen tundra. The organisms, if they survive this brutal odyssey, could find themselves in an environment where they might thrive. This leads us to ponder a profound question. Could seeds of life have hitchhiked across space from Mars to our blue planet? The possibility changes our understanding of life's resilience and its boundless potential to spread across the cosmos. If we're Martian descendants, what does that mean for us as a species? Imagine for a moment that the cradle of humanity was not nestled in the valleys or along the rivers of Earth, but rather on the dusty, red plains of Mars. This notion isn't just a spectacular plot twist in our species' backstory. It's a hypothesis that could revolutionize our understanding of life itself. If life did indeed start on Mars and traveled to Earth, this interplanetary exchange suggests that life is not just a rare occurrence, but potentially a cosmic imperative. This idea that life inherently seeks to spread and flourish could lead us to expect and search for life in places previously deemed inhospitable. The implications for astrobiology are profound, as every nook and cranny of the cosmos gets a second look as a potential cradle for life. On a more philosophical note, knowing we are Martian could fundamentally alter how we see ourselves. Earthlings no longer, but children of two worlds, might feel a renewed responsibility towards the stewardship of not just one, but multiple planets. This could catalyze a shift in how we approach space exploration, no longer as visitors, but as returnees, looking to reconnect with our ancestral home. This reconnection with Mars could drive unprecedented technological advancements. Consider the new technologies required for sustainable life on Mars. Advancements in habitat construction, life support systems, and terraforming. Each of these technologies not only helps us thrive on Mars, but also provides solutions for sustaining life on our increasingly fragile Earth. Moreover, our Martian origins could push the boundaries of our biological knowledge. How did life adapt from Martian environments to Earth? What can this teach us about resilience, adaptability, and evolution? These are questions that scientists would be itching to explore, potentially leading to breakthroughs in genetic engineering and biotechnology. Our Martian ancestry could redefine our place in the universe. As we stand on the brink of this potential identity shift, it's clear that the red planet offers more than just answers. It offers a new perspective on life's possibilities across the cosmos, challenging us to rethink what it means to be human and perhaps what it means to be Martian. Armed with rovers, satellites, and an insatiable curiosity, our quest for answers presses on. As we continue to gaze up at the red speck in our night sky, the allure of Mars invites more daring missions and deeper investigations. Among these, the Mars 2020 mission with its Perseverance rover plays a pivotal role. Perseverance is designed to explore the surface of Mars like never before, equipped with tools to drill into Martian rocks and soil, seeking signs of past life and collecting samples for future return to Earth. But the exploration doesn't stop there. The European Space Agency, alongside Roscosmos, embarks on the ambitious ExoMars program. This initiative aims to send a rover named Rosalind Franklin to Mars, its primary mission, to drill up to 2 meters below Mars's surface, reaching areas where ancient life might have been shielded from the harsh Martian environment. Here in these subterranean relics, the secrets of Mars's past await, potentially holding the keys to the planet's habitability. Moreover, these missions are complemented by orbiters that scan the Martian atmosphere and surface, mapping out the planet in unprecedented detail. These orbital eyes help guide rovers to points of interest and analyze shifts in weather and climate, providing context to the surface discoveries. With each rover wheel's turn and every pixel of data transmitted back to Earth, we peel back another layer of the Martian mystery. Every new discovery brings us closer to understanding our cosmic origins. As we gaze up at the night sky, the red planet beckons with secrets of our ancient past. Imagine, if you will, a time before the Earth was teeming with life, when Mars might have been the cradle of life itself. Throughout this exploration, we've delved into the tantalizing possibility that life did not start here on Earth, but rather on the dusty red soils of Mars. We began by contemplating a Martian Genesis, the idea that life's seeds might have been sown on Mars before being transported to Earth. This notion isn't just science fiction, but is grounded in scientific inquiry and hypothesis. The conditions on early Mars were surprisingly Earth-like, with evidence suggesting that liquid water, an essential ingredient for life, once flowed freely. From there, we explored the mechanics behind the survival and potential thriving of microbial life on Mars. The discovery of biosignatures in Martian meteorites and the ongoing research into extremophiles, organisms that survive in Earth's harshest environments, lend credence to this theory. These extremophiles could be cousins of Martian organisms, both adapting to extreme conditions in their own ways. The concept of panspermia took us on a galactic journey, contemplating life as a cosmic voyager. Could spores from Mars have journeyed through space, shielded from radiation, eventually reaching and seeding Earth? This hypothesis stretches our understanding of life's resilience and its boundless possibilities. We also pondered the profound implications of a Martian origin for life. If we are indeed Martians by descent, this reshapes our understanding of life's uniqueness and interconnectivity in the cosmos. It prompts a reevaluation of our place in the universe and fuels our drive to explore further, reaching out to the stars from which we may have come. These reflections bring us to appreciate not just the scientific journey, but also the philosophical and existential ponderings it ignites. How does the possibility of our Martian legacy influence our view of life on Earth? Does it make our exploratory missions more crucial, knowing they might also be a journey to our ancestral home? Whether Martian or terrestrial, the search for our origins continues to inspire generations across the vast expanse of space. Today, Mars is a cold, arid world, but its secrets are not all lost to the sands of time. Journeying through the possibility that life might have sparked on Mars before migrating to Earth, the concept isn't just science fiction, it's a scientific intrigue that stretches our understanding of life itself. This exploration invites us to look differently at the red planet, not as a barren landscape, but as a potential cradle of life. Keep looking up, keep wondering, and never stop asking, what if?